Hello, hello. Okay, some people still joining. Hello, Adil. Hello, Minatallah. Hello, Aya. Hello, Bakir. Hello, Dominic. Hello, Hajar, Lassen, Makila, Minatallah, Pacman, Pat, Sabah, Shadowbanks. Okay. So I guess we start. So let's wait 3 minutes and then we start. So we don't repeat again. Don't be shy. Write hello in the chat. Say hi. Say something. Just to know that you are alive. Okay, Omar. Hello, Omar. How you doing? Hello, Pat. How is your weekend going? Two minutes and we start. It was amazing. Nice. Who did finish foundation project? I know you did. How it was? Of course you. How it was? What was like the hardest part? Let me tell you, maybe the presentation. I think the foundation, by the way, it's gonna be reviewed by mentor from now on. So the people that passed the presentation foundation with peers, they are maybe lucky. But not sure if this information. Okay, hello new people that just joined. I hope you guys having a good weekend. Let's continue on this LeetCode. So if someone new here, he have no idea how this work. So we at the start of the year we start with this handbook, Take Interview Handbook. It have like a planning for 3 months, and we did reach the week 10 and we did take a break. So some of these are like a bit hard, but like we did, because we did start from the beginning, it was like a bit easier to get into it. If you wanna like see the past PLD, like you can check this, or like there is a channel for it. Like there is from the beginning of the week 1 until the week 10. You can just go through them, or like go through them alone, and then so like set up like a plan, like a week plan. Like every weekend, say I'm gonna solve at least 3 LeetCode of the one that they give us here. And if you're like stuck at something, you can like watch what we did in each session if you need help to understand. Now today we're gonna do 2 LeetCode. So we're gonna do like this one, continue with most water, and we're gonna do which one? Binary tree right side view. Also, like if someone wanna host some session and like solve some of this LeetCode, you can check this document and just send me a message which one you wanna present or like host, and yeah, just jump to stage and host it. You don't need to like understand everything. You can just lead the session and we solve it together. So let's start with this binary tree, and Sabah gonna do continue with the most water. So let's see. Let's read first. Binary tree right side view. Given the root of a binary tree, imagine yourself standing on the right side of it. Return the value of the nodes. You can see ordered. You can see ordered from top to bottom. Okay, so 1, 3, 4. Okay, root 1, 2, 3, null because there is no node here. 5, then 4, null 4. So the output is 1, 3, 4 because if I stand here I see 1, 3, 4. And by the way, please, if you have any question, like, don't hesitate, you can write in the chat. I am not getting any audio. I am not getting any audio. Oh, you can't hear me? Wait, guys, do you hear some music? Sometime I forget to... I hope I'm not sharing music. Oh, he's muted. Okay. I think I will turn off the music so you guys don't sleep. Okay, so that music is for me, not for you. Yeah, but like it will make you sleep. Okay, I guess now it should not be any music. So I guess the problem here is they give us a tree and we need to get the output of list of the nodes value of the one that's in the right side. Let's take this to the Excalibur and see how we can understand it more. Code creative. Okay, let's see. Okay. Code creative, if you can hear me, please mute your mic. You have like a background noise. Then I will unmute you. So this is the problem. And this is the example. What about the rules? The number of nodes in tree is in the range of 0, 100. Okay, so I don't think this is gonna affect us. Like the value. I don't think it's matter what's the value of the inside the node. Please, if you have any question at any point, if you want me to repeat or something, let me know or write in the chat. So, what do you think, guys? Who didn't understand the problem? So if I have this, if they give me this tree, I should have the output 1, 3, 4. If they give me 1, 2, 3, if they give me 1, 3, this should give me 1, 3. Okay, let me paste the link. So this should give me 1, 3. And the last one, if it was empty, like only the node, or like empty node, empty tree, it should be empty. And I believe if it was like 1, 2, maybe here 3, and let's say here is 4. like this. It should be 1 2, should be 1 2 4, because if I stand from this side, I will see this level, this level, this level. So this level I will see 1, this level I see 2, this level I'm gonna see 4. So I guess that's what they mean. Given the root of binary tree, imagine yourself standing on the right side of it. Return the value of the node you can see. Order them from top to bottom. So if I'm standing here, and if 4 wasn't exist, I will see 5. So it's gonna be 1 3 5. I guess that's the problem. Now how we can, or like who did not understand problem, or like who is have some addition to it? What do you think? Do not be shy, open mic and talk, or write in chat. I guess it's clear, so we maybe can jump directly to pseudocode. Let's see the code that they give us. So this is the code they give us. It's a function right side view. We have a root, so they're gonna give us a root, which is a node. To have left, right. To have a value left, right. Okay. Let's take this just to like keep it close to us. If you wanna do pseudocode, or like what will be like some solution, we can do like maybe DFS, like recursion. So maybe we launch DFS on this one, on this node, and we check. So like if we wanna simplify it, is like what we're saying is like we're gonna go to each level. So this is level 0, this is level 1, and this is this is level 2. So each level I wanna take the right side node. So like if I go to level 0, I will add this to somewhere. If I go to level 1, I will, so I'm gonna always start maybe from the right side. So I will start from right side, or like I will go to the right side, I add this there, but I will not add this because maybe in that level it's not empty. Maybe if we did like a hash table, so level 0, level 1, level 2, and then I add 1, and then when I launch DFS on this, it's gonna launch on the left side, on the right side. I guess we need also left side, right? Because what if this 4 doesn't exist and I have some nodes here? No right, you go left. So I guess we in our DFS it will be like we're gonna launch it on both of them, right, for all level. DFS on the right for all level. So we launch it here on this one. So this launch DFS on this and on this, and then when it launched DFS on this also launched DFS on the right and on the left. Left there is not. And somehow we need to keep track of the depth 0, 1, 2. So when this reach to the end, which is like the base, this gonna go to its own level, which is level 2, and it's gonna save the value of it, which is 4. Let me remove this beautiful art. So 4, right? And this gonna return, this gonna return. Why this didn't save? Let's say it was here 2. Why it didn't save 2 here? Because maybe we added check. If in this depth there is already a value, we don't need to save. You can skip this, because we can control which DF is gonna be launched first. Okay, so DF is, think of it like a recursion. Recursion, where is it? Or like this video will like explain it really well, but you can like see maybe like something explanation. Let's see DFS explanation quickly, because I don't like remember it's like in depth, but I know how it works. So DFS is an algorithm for searching a graph or tree data structure. The algorithm starts at the root top node of tree and go as far as it can down and given branch path, then backtrack until it finds an explorer part and then explore it. Okay, I guess this will make you more confused. Probably watch some YouTube video about DFS. At least for me, this definition make me more confused. Maybe this is good. Okay, let me try just do a explanation. So imagine we have a tree like this, like this. So this is a tree, and imagine each tree have some value. With DFS is just a algorithm or a way how to traverse the tree. It's like a recursion. So you launch DFS on this, a function on this, and this one also gonna launch the same function like with the recursion on this too, and this one gonna launch a function on its child, and they are like recursion, so they are all waiting for each other until like they reach the base, like in recursion. When this reach the base, then it's gonna return or backtrack to this with a certain value, or like depend, and then this gonna return to this. So when this like gonna launch DFS, is gonna be waiting until its child returns something to it, then it's continue. We're gonna see it in the, when we're gonna start coding, you're gonna see it more. So we said, now we save this for here, but even the DFS was launched on 2 will not save the value here, because it's already saved, and we want the right side, right? We want always the right side, so we're gonna ignore this one. And also when this one gonna reach here, it's gonna find that there's already a value here, so it will not take it. Now this gonna return to this, this gonna return to this. Now this gonna go and save its value, or maybe it already saved it. Did it already save it, or I guess it already saved it. Yeah, so we start from the top. Okay, yeah, we start from the top. So 1, we launch DFS on 1, it go directly, it save 1, and then when we launch DFS on 3 and 2, 3 did save the value here in level 1, and then the 2 It's go also to save the value. It found that tree already save it, so it will not do anything. And then it tree launch defs on 4, and it to also launch defs on 5. And because we start from the right side, so this is gonna be the one that's gonna execute first. And then this one gonna save it 4. It's gonna save it in level 2. Okay, I think this will work. Yeah, I think this might work. Anyone have any idea? Brainstorm with us. There's also another way. Instead of hash table, we can do maybe array and use the index, like depth 0, index 0, depth 1, index 1, depth 2, index 2. Okay, let's write a pseudocode for this. So if someone like finding it hard to follow, it's okay. You probably just don't understand DFS or recursion, but maybe when I write code, it will like look more understanding for you. If not, then you probably just not familiar with DFS, which is fine. Like me too. It was new to me for some at some point. So just like after you start this, DFS is gonna be easy for you. Like you will understand what's going on. Okay, so if we wanna do pseudocode, how it's gonna be? Let's use maybe the array, because I think it's simple. Because it is in order, right? Because I'm gonna go 0, 0, I'm gonna save it. So 1, I'm gonna save it in index 0. 3, I'm gonna save it in index 1. So I can use the index as a check. Okay, let's see what's gonna happen. So first, what we need to do? We need place to store the results, right? Did he give us a place to store? Okay, we're gonna save a list int. A list of int. So let's say results, it's empty list. Let me zoom a bit. Results empty list. Then we're gonna have the function DFS. So let's say DFS. Now this function we need like to keep. So we need to launch it on the root. The root here, they give it a root. So we're gonna launch it first at the root. But we need to keep track of the depth. So I need to keep track of the value. So when I launch this DFS here, this gonna be the depth 0. But when I launch it on the children, I need to increment this depth to be 1. And then this gonna increment it, it's gonna be 2. So I can use another argument here and just put like do I call it depth? Like I put okay, I can put 0 because it's depth 0, and then later inside the depth. By the way, this is just a name. I can call it Nux. It's just a function. It's not like def is something special. Let's call it def is. So this DFS function have 2 parameters, the node and a value which we're gonna use it as a depth. So let's create this function above. dfs, like dfs. Now this gonna be the root is the node of it, node, and this 0 gonna be the depth. Okay, so because this function gonna be recursion, first thing we do is like we're gonna check the base, right? Okay, now when I launch this function dfs here, I give it this node 1 here, and I give it 0 depth, which is what I did here, right? Now this function gonna run the code that is inside here. Now I didn't write any code yet, but I know it's a DFS algorithm, so it's recursion. So I know in recursion, first thing I do right here is what is the base. Now the base is where our code gonna stop, because when you launch recursion in this, it's gonna launch it on this and this and this and this, and then it stop here. Now why did it stop here? Because there is no node. There is nothing here. Node is null. So this is our condition. When the node is null, you should stop. So if node is null, just return, for example. If node is null, return. Okay, if node is null, is return. Okay, that's our base. Okay, now we have a base. Now we said we're gonna launch DFS on this one. Why we launched DFS on this one? What was the point? The point is we wanna have an array that have 1, 3, 4. This is the point. So I need to save this one on the array, on the depth 0. So I have the depth in this value right here, and I have the node in here, so I can access the value of it, and I can save it in the depth 0, which is like the index 0. Okay, how are we gonna do that? We're gonna how are we gonna write this? Okay, maybe we say get value of node, save it. Okay, too much stuff going on. Go away. Okay, we get the value of the node, we save it. Where we save it? In results. But it doesn't make sense because we want to save it in the index 0. And because this is, I think that will happen automatically, right? Because this is the first node. Automatically it's gonna be index 0. So save it in the results, but when we're gonna go in the child, we're gonna find like we may find a problem because this gonna add to the list and this gonna add to the list. So we need to add some condition that's only this one add, not this one. Okay, let's see how we can do that. So get the value of the node, save it in result. Do we keep it simple like this? Save it in a result, or like we can add save it. Let me add the new line. So get the value of node, then check if that index in array is empty, or is empty. How do I know if it's empty? check if that index. Nah, this is will not work, I think. So my point is like, if there is some value here, I will just skip it. So I will only save it if, okay, let's just write if it is, don't need to know if it's empty. Check the length of the result. Okay, so we can check the length of the result. That's a good idea. So if the length, if the depth, so at the first the result is empty, right? So the length is 0. So we're gonna check if the depth equal the length of result, then add it. And when I'm gonna reshare, I'm gonna check again the length. The length gonna be, at this point, gonna be 1, because there is one value. If 1 equal 1, then I'm gonna add it. And this one, when it's gonna come to add the value, it's gonna check if the length equal the 1. It will not add it. So this is a good idea to work with the length of the index. So check if, or like we can say, if length of result equal the depth, what I'm gonna do, save the value in that index. Okay. Now this is our dfs. It's getting more complicated, but I think it will make more sense. So first we check if node is null, gonna return. So in this case the node is not null, so we're gonna continue. We got the value of node 1. Wait, we get the value. I guess we don't need to get the value because we have the length now. We're just gonna check if length of the result equal to the depth. We have depth here. If it's yes, then save the value in that index, value of the node. What if it wasn't equal the length? So in this case it's equal the length, right? Because 0 and the length of the result is empty, so it's 0, so we save it. What is next? Next we want this node, after it saved the value, it will launch the FS again on the left side and the right side. The right side on the left side. Okay, let's launch it. Launch DFS on right, increment depth +1, right? Because the depth here was 0, now we're gonna go +1, and same for left side. Or like, let me write launch DFS on left, increment depth +1. Now let's see if this is gonna work. So we did launch this, it give us 1, then it save it, here is it, and then it launched DFS on the right side. So another function of DFS that's gonna do the same thing again. So this DFS here is gonna run again here. It's like a recursion, a function calling itself again with different parameter. So this gonna run first. Wait, are they gonna run both of them at the same time? No. Until this one come back, return, then this one starts. So if I can remove this, it's actually gonna launch it on the right side, and until this return, then this one gonna launch. Right? Is that correct? Someone correct me, maybe I missed something. I think it's execute this line until this one return, then it will. So this is gonna solve our problem, because if this saves some value, that's also tricky. Yeah, no, I think I'm just overthinking. Yeah, so if this saves some value in index 1, when this gonna go here, it will not save that value in index 1, it will just keep launching the fs on next node. Okay, that's good. Okay, we can transfer this to code. Is that all? I think that's all. Yeah, I think that will be all. Let's launch the code and do a simulation and see if it's gonna be fine. So what will be the code? The code is the same thing, just gonna be, just I need to clean this, or like maybe we write the code directly on. Maybe directly here. So we have, oops. So first let's create this function. So div, we call it dfs, we give it node and depth. Okay, let me open the chat. Okay, if someone writes something in chat, I can see it now. So if the node is not return, how we can do this? If node, so in JavaScript I will do null like this, but in Python is null like this, or null. Completely forgot. Null. Node. Wait, there is this in JavaScript? In Python? I don't think so. None. Oh, none is null. Okay. If node is none. So null is like null. None. Okay, null uppercase. If node is none, we will just return, right? Because we reach the end, and if I keep pushing DFS, launching DFS, this one gonna launch it, and then it's gonna be the node doesn't exist, which gonna be none. So it's gonna just return. It's gonna do anything. In case it wasn't none, we're gonna check if the length of result equal the depth. Okay, results. So maybe I should create a result first. Result's gonna be just array. If the length of results equal the depth, so the depth is here, and the length, if is it like len, if len of result equal, if the len of results equal the depth. Okay, I feel like something is wrong here. Is this correct? Or equal? Is there like equal or like equal? Oh my god, I forget completely Python. Okay, depth. Nice. Save the value in that index. Okay, so I wanna, if the length of results equal depth, I wanna save the value here. Now why? Why if this equal, I need to save it? because that is our goal, right? We want to get our goal is to have 1, 3, 4. So as long I am in the right side, or like as long I am in the first on the right side, I will save it. And because this is the first node, it like you can say it the first thing you're gonna see. So the depth 0 and the length 0, so I'm gonna push it. So results dot append, then node, that's value. So this node have value right here, which have the value. So this gonna push it to the array. Now after we did that, we're not gonna stop there, we need to keep going to the children. So launch DFS on the right side. Okay, now to launch another DFS, we're gonna use the same function that we call here. It's gonna call it it's gonna call itself. So DFS, this time I'm gonna give it the right. So I'm gonna launch it on the right, and because this node I can access the right of the node, so this one I can access the right node of it, which is 3. So node right, and increments the depth. So this depth is take 2 parameters, the node and the depth. So the depth here is +1, depth +1. So whatever the depth value was here, I'm gonna add 1 to it. And I'm gonna do the same for the left side. So this way, launch DFS on the right side, increment the depth. Launch DFS on the left side, increment the depth. Now we said something here, DFS roots, because here the DFS function is just define the function, it's not running, right? I didn't call it yet. Now I want to call it on DFS root 0, which the root of the node. So DFS, now we have the access to the root, which is this one, root. Now the root is depth 0, so 0. Now this function gonna execute this lines. It's gonna check if the node is none, the root exists, it's not none. So it's gonna check if the length results, if the length result is 0, is length result, which in this case is gonna be 0, and the depth is also 0, right? 0 0 equals 0, so it's gonna append it to here. So here is it, append it, and back to the front. Okay, so it did, so this is 0, it did append it. Now it's gonna go to again to this line, which gonna launch another DFS on the node right, which is 3, right? So this launch DFS on 3 with the depth +1, and depth was 0, right? So depth +1 is gonna be 1. So we are now in depth 1. Now this function that's launched on this DFS, it's like also the same. It's gonna check if the node exists, it doesn't exist. The length of the result is what? Is it have 1 value, so is 1, and the depth is 1. So it's gonna append it. Here's the 3. Then it's gonna launch DFS on the right side. And by the way, the DFS that was in the beginning, it didn't launch on the left side. It's still waiting all this to return to launch the left side. So after the DFS on the 3 finish, it's gonna launch another DFS on the right side, which gonna be 4, and the depth increment to 1, so 2, and the length of the array is 2, so it's gonna add 4. right here. And then it's gonna launch Davis on the right side. So 4 gonna launch Davis on the right side. It's gonna return none, or like it's gonna return nothing, because there is no node here. And because this didn't like it's return, it's gonna, the 4 gonna launch another Davis on the left side, and the left side also gonna return none, and then this gonna return to 3. And 3, the last time he did launch Davis on the right side, now he gonna launch Davis on the left side. Actually this is kinda, we can do like if node left, because so like we don't launch Davis when it doesn't exist, the node. Doesn't make sense, right? What do you mean on left? Yeah, so because we have this case like this. So let me bring your question. So why do we have to launch Davis on left since the observer is the right?
Oh,
That's a good question.
sorry. I don't know what's happening. I don't know what's happening. Yeah, I think his mic is.
What, can you repeat? So is it so because we can have 1, 2, 3, 4. So here's nothing, here's nothing, here's nothing. Now when if I stand on the right side, when I look, what do I see? I see 1, I see 2, I see 4. But 4 is on the right side. Sorry, on the left side, right? So I still need to check that. Do you get it, Dominic? Because this one didn't save in the depth 4, this one didn't save in depth 4, this one didn't save in depth 4, this one gonna save in depth 4, which is like index 4 in the array. Yeah, so this I add this right here because if there is no node, there is no need to launch Davis. It's just for optimization, maybe. So this one 3, it's got nothing from the left, so it's gonna return here. Now the node root finally finish this line, so it's gonna check if the node left exists. It's gonna find it. It's gonna launch Davis on the left. Now here's the tricky part, like the important part. Now when these two gonna run, it's gonna, what's gonna do? Gonna check that the node it exists, like, so it's not gonna return. It's gonna check if the length result equal depth, and the result already have 3, and the depth here is 1. So 1 and 3 not equal, so it will not append this value. It's gonna continue launching Davis on the left and the right, left if it exists, and the right again when it's gonna launch it, it's gonna find that, okay, so this is depth 2 and the length of this is 3, so it will not add. So this is like how this Davis solve this problem. If someone have question, please go ahead. Because the right node might, yeah, correct, listen. Okay, let's run it. And let's say, okay, we have wrong. What did we miss? We did not return results. Oops. Yeah, we should return results. Run again. Wait, we didn't return results and we have one case wrong. Oh, nice. Submit. Okay. Sometimes this like show low score, but if you submit again, it will show high score. So do not take care of this a lot. So it worked. That was it. I hope you guys enjoy. We still have one more let's go to go. And let's go through it. Oh my god, it's going lower. What? Let me stop here. Okay, so that was it, guys. Who have any question? Who have any question? No one? No question? Okay, Sabah, you wanna go to the next let's go?
Yes, I will take it from here.
Okay. Let me stop screen.
Is my screen visible?
Not yet. Maybe restart.
So, hello everyone. We will try to solve together this LeetCode container with most water. So, the question says you are given an integer array of height of length n. There are n vertical lines drawn such as the two endpoints of ETH line and E0 and E. Okay. Find two lines that together with the x-axis from a container such as the container contains the most water. In simpler terms, we have an array of heights, right? And each integer corresponds to a height in our y-axis. So 1 has the height of 1, 8 has the height of 8. And this array, we are supposed to find basically the volume between two heights that contains the most water. So basically we need to find 2 points in our array that can hold the most volume. So in this case we have 8 and we have our 7, and if we calculate the volume that this can hold, it would amount to, I believe, 49. So this combination of height and distance is the most water this whole contraption can hold. So let's take this image, put it here. Take this. Okay. So here, as I said, each integer in our array corresponds to a height. And in this case, the height 8 and the height 7 with this distance gives us the most amount of water. So in this case, for example, between 1 and 8, it would hold only 1 because the minimal distance, if we put water in here, it will only fill up until the minimum height between the two, right? The water cannot keep going up. So in this case, if we were to fill this container with water, it would be till here, right? And this little volume would be the height of the minimal or the minimum between the two heights times the distance between them. So in this case, 1 by 1. This would give us 1. Okay? Now, if we were to, for example, do between these two, if we were to calculate the volume between these two, again, it would find the minimum between these two, right, which is 1. But this time we have double distance. The distance is this 1 plus 1. So in this case, the volume would be 2, right? If we were now to find the amount of water that between 8 and 7, we calculate the minimum between these two heights, which is 7, right? And we multiply it by the distance. So I have 1, 2, 3, 4, 5, 6, 7. And 7 times 7 is 49, which is the answer that they provided. So they said the above vertical lines are represented by array 186254837. In this case, the max area of water, blue section, the container can contain 49. So 49 volumes of water. So if we were to, for example, try to see 8 and 8, since intuitively the could hold the most amount of water. So 1, 2, 3, 4, 5, and 8 times 5, I believe, is 45. And 45 is lesser than 49. So this is not the maximum amount this whole contraption can hold. Is
How do you calculate the distance? Is like the difference between.
So just like here we have 1, 2, 3, 4, 5, each height has like an index. So here we would have 0, 1, 2, 3, 4, 5, 6, and the distance between, for example, 8 and 7 would be the distance between 1 and whatever index this would have. So for example, distance between 1 and 6 is 2 minus 0. Distance between 5 and 8 is, I believe, 4 minus 1. So it's the index of the index of the right one minus the index of the left one.
And what is the formula to calculate like 49, for example?
So it is the minimum height times the distance. So the minimum height between the two sides times the distance between them. In this case, the minimum height between 8 and 7 is 7. And the distance between them is 1, 2, 3, 4, 5, 6, 7. And so it's 7 times 7, 49.
This is really complicated.
Not at all.
Of course.
Okay, we'll keep this here as our... Okay. So is the question understandable so far?
Does anyone have question,
If
please?
if we have a container of 1, 1, so that would be like this. And the height of this is 1. And of this is 1. Then the minimum between those two is still 1. And the distance between them is 1. So the answer would be 1. And they said that n is the height dot length. So they are giving us, yes, they're giving us the height. And n is the length of those, the array of heights. And the array has at least 2 elements. So that's good. And the height can be from 0 to 10 to the power of 4. Okay.
So it's like we need to calculate each one, like all of them, or like there is a way to like.
We can explore first the brute force way, and then we can try a more like smart method.
Maybe like starting from the bigger one, like maybe we order them.
Okay, let's start with the brute force to just understand the issue, and then we can branch out from there. So brute force, basically, you're gonna calculate the most amount of water in every single case, right? From 1 to 8, 1 to 6, 1 to 2, 1 to 4, 1 to 8, 1 to 3, 1 to 7, and then you go back from 8 to 6, 8 to 2, 8 to 4, and then you go through all these cases, and at the end you have one max between all of them. It is not the smartest way, but it is a way to find the maximum amount of water. So first of all, you have your variable that holds an initial amount, right, which is 0, and then you loop through the first time. So with this as a start, so imagine if you have 2 pointers, right? Imagine you have 2 pointers. No? Yes. So imagine you have these two, right? And you want this to be the start and this the one that keeps moving. So say this is the hours hand in the clock and this is the minute, right? So this one is the first loop. This is the inner loop. So you start here and you check this combination, right? And you save that. And then you check this combination and you check which one holds more water. So in this case, this would hold 1, this case, and this one, it would hold 1. In this case, it would hold 2. This case, it will hold 3, because this is the minimum. The minimum, and then times the distance. This case distance is 1, distance is 2, is 3, 4, 5, 6, 7, 8. So the maximum amount of water it would hold in this scenario, in this first run, is 8, right? And then we go back. This moves one place, and then this takes its place after. We don't start from the beginning because we already know this one, right? So we take the second after it, and it checks. In this case, we have 6 and 7, and the distance is 1, then the maximum amount of water is 6. It keeps going, and then here it is 2, 2 times 2 is 4, and it keeps going through each iteration, and it keeps calculating the current amount of water and then the max between what we had and what we have right now. Does it make sense?
Yeah.
So if we start from a first loop, right, loop 1, it would start from the whole height. So it starts from index 0, right? And then we would have a second loop, so it's loop 2, that would start from index, let's say, if we were to give this, for example, E, it would start from index of E plus 1. Because we don't want these to have the same
starts
index, and we don't want the right one to be on the left, because everything on the left of this one has already been calculated, right? So say we have it here, all of this has been calculated, we don't need to redo it. And then you calculate the max. So the current, I would say, is the minimum between the two heights times the distance. And then the max would be I guess max H2O would be the maximum between the current and the maximum, the overall maximum that we have. Does it make sense?
No.
No.
I'm still trying to understand.
Okay, which part?
So current is the green, right? Or like
so the current is the current volume of water between the 2 pointers that we have.
Okay, minimum.
So we calculate. Yes. So the minimum of between the two arrays, as
between the green and the red, okay?
Yes.
In the distance.
Times the distance between them. Okay. So this is the current amount of water that this container between the two pointers can hold.
And then the max is between.
And then we calculate the max between this current and the overall mass.
Okay, I see now.
The one that we currently have and the one that we have overall for everything.
Okay, I see. Like, so we're going to the right and comparing with the previous one.
Would you mind repeating that?
So like we are gonna keep going to the right and comparing with the previous one, and we're gonna leave only the bigger one.
Not just the previous one, but with the overall max. Yes.
Okay. Like previous one, like the previous max, or like the max one.
Yes. So each time you change one of the pointers, you recalculate everything again, and then you compare it with the max.
Okay.
Okay, makes sense. No questions?
Yeah. What about you guys? Any question? Do not be shy.
So let's code this. So we have an initial value to max, which is 0. The first loop is gonna loop through the entire, so it starts from index 0. So for, let's say, E in heights. The second one needs to start from the index above E, right? So in this case, we would need to take also the index. So we would have index E, and we would use enumerate. Or we can just have for index E in length of height. Whatever is simplest. But enumerate basically just gives you both the index and the value of each element. So now that we have the index, we can start from this index plus 1. So if E starts at 1, we want G to start at index of E plus 1. So in this case, for index of G and G in enumerate of height, the index of E plus 1. Does this make sense?
Can you repeat this?
So E starts from the very first index. We want G to start from the index after it.
Okay, yeah. Now it makes sense.
We want G to start from 8.
Next one, yeah.
So height will start from the index. So in this case, the first index E is going to be 0. The first index G is going to be 1. Okay?
Yeah.
I think they should put a colon after height plus 1 in order to return a new list.
Yes, you are completely right, yes. Good. So this basically just starts from the index until the rest of the array. Okay, now current is going to be the minimum between the two heights. So it's going to be min E and G times the distance, we said, between E and G. How would we calculate the distance between E and G? We already know that this height starts from index E plus 1, right? So already index G is the distance between G and E, right? So if index E is here and index G is here,
so
index G is already, index G is already a distance between E and G.
Okay, I see. So it's equal index G.
So if index G is here, and index G equals index E plus 1. Let's go back here. So this is E. And this is G. If we were to say that E is 1, then 0, 1, 2, 3, 4. The distance would be 4 minus 1. But index G is going to be 1, 2, 3. Because G is relative to E. It starts after E. Does it make sense?
So like we need to do -1?
Sure, actually.
Okay, so let's maybe to put numbers. Let's put numbers there.
Okay. So in this case, this is 1. And this is... This is going to be 4 relative.
Yeah, continue.
So in this case, it starts from 1. Index E is 1. And here, the G is going to be 0, 1, 2, 3. So it's going to be 3. So 3 minus... If it was 4, which is the actual index, 0, 1, 2, 3, 4, it's going to be correct. 4 minus 1, which is 3. So I believe this is correct. If this was here, and this was here, for example, this is going to be 2. And this is going to be, since it's starting from here, it's going to be 1, 2, 3, 4, 5. And if we start from the very beginning, 0, 1, 2, 3, 4, 5, 6, 7. 7 minus 2 is 5. So I think it is correct. So index G is our distance. Now the max is going to be the maximum between the current and the overall maximum. So we can easily do max and current. And then we return our max. Should we check?
Let's see.
Oh yeah, I should return, not just look. Okay. So it's given 42 instead of 49, and it's given 0 instead of 1.
Since that the distance should be EDX plus G, or like EDX G plus 1.
G plus 1. Can you explain why? Index G plus 1, but why?
Hey, can you hear?
Yes, yes, we can hear.
Okay.
Can you hear me?
Yes, we can
Yes.
hear.
So, if we use the second list, which means the high with the index I plus, I don't see it here. Can you go to the code? Yeah, so in the second loop, if we use the second loop, because the distance should be index G minus index I if we use the first high. if we use the second one, it should be index G plus 1 because the index, as we know, starts from 0, right?
Yes.
So let's say we find the current from the first loop. The distance should be like 1, not, and the index G is 0.
I'm not sure I completely understand.
The enumerate, is it starting from 0 or 1?
Index E is starting from 0. Index G
No,
starting
no, the enumerate.
Enumerate. Starting from
starts from 0.
So the index G is 0.
Yes.
And we suppose that we find the current is in the first loop, we find the solution from the first step.
I think I get what he's saying, because in the first, like the second loop, the index, or like the value gonna be, or like the index gonna be 0, like the current.
I think I also understand, yeah.
Like,
Both
can we-
E and G are gonna be 0.
so like if we did multiply by 0, it's gonna be 0, right? The current.
Yeah,
If we
but it should be 1. I think I understand. So in both these cases, the first iteration is gonna be index E equals 0, index G equals 0. Because we're starting from here.
from here, yeah. So we need to do +1 maybe?
Yeah, that makes sense. So okay.
Oh,
All right.
nice.
That is nice.
Nice catch, lesson.
Yes.
We'll
But this one will not submit because it is too slow. It is too slow. It will not
Oh, maybe because to enumerate?
No, it is just not optimized. This method of brute forcing this solution is not the actual solution. So now we need to go back to the drawing board and think of another way to actually do this.
Okay, what will be... Okay, why it is not the perfect solution?
Because
we lose
it
time?
brute forces everything. We lose time in trying to maybe look for in the smallest
Okay, what if we order? No,
Okay,
we can't
say we
order. We're gonna lose the... We can't order because we're gonna lose the container shape, right?
I mean, I haven't explored that possibility, but we sure can.
I mean, if we
Right.
order them, that means the container gonna... Because
Yeah, but there is a way to order them without actually losing the index. If we save the index, for example, in a dictionary, maybe.
Oh, okay. Okay, yeah, I see.
But I have not actually tried this method. Let's now explore a method that I've actually seen. It's called the two-pointer method, right? So now the issue is why is it so slow? It's because it explores heights that are too small, even if you have a big height, right? So for example, say you found this very big height, it still explores these smaller ones. Even if you have this, it still keeps going and finding every single one. When you have this one, you should stay with this one because this is technically the highest one. It should stay with this one and then maybe try to find the highest height, basically, with like, okay. So say in this case you have these two pointers, right? And you have found that this is higher. you still lose it. You still abandon it to keep going through each and every one, when you should actually stick with this one and maybe look to change the other height. Maybe find a height for this pointer instead of this one. So the actual two-pointer method calls for having two pointers at the sides, and then you check which one of your heights is the smallest, and you try to change that. So in this case, we have a height of 7 and a height of 1. Logically, which one should we change? Which one should we try to explore a bigger height? 7 or 1?
Like 7, the bigger one.
No, but which one of these two should be changed to a bigger one?
Okay, what is the color? Is red small?
Yes.
This should stay the same, like this, because the green is the higher.
Green is the higher, good. But red should also try to find a bigger one.
Why? Oh yeah,
Because
true. Because we're looking for a bigger number, yeah.
Exactly. So this one should try to find a bigger one. So it moves up. And now I have an 8 and I have a 7. So in
But
hopes of
how
finding,
I know that the next one is not higher?
I just move. I am the smallest height. I should move to
No, I mean-
hopefully a bigger one.
No, I mean we move right now to the bigger one, the right one, right? Move it,
Yes.
move it.
It could be another smaller one.
Yeah, that's what
And
I mean.
if it is smaller than this one, it should move. It should keep moving until it is bigger than this one. So let's
What
call
if
it
it
left
doesn't
and right.
exist?
What do you mean?
What if that doesn't exist? Like
Give me a case.
What if the height? What if the bigger one, the green one, is the biggest one?
That is good. Then I have just gone through all the possibilities with this one, with this biggest one. Say for
Okay,
example,
I see what you mean. Okay, so I
I
want the height. Okay, let's go back. The green. So the green gonna be always on the bigger one?
not necessarily, but you try to have your pointers on the biggest heights. And okay, say for example, okay, and then you have this pointer here and this pointer here, right? This one is clearly the biggest height of them all, right? Then this one is smaller. The left pointer is smaller than the right pointer.
Wait,
So
can I
it
ask, how did green reach there? What was the logic?
oh, it starts from there. It starts from there.
Okay, it
The
always
both
starts from the
pointers
end?
start. Yes, it starts from opposite sides.
Okay, I see.
Okay? So now the left one, the red one, right, needs to change because it is smaller than the left. So it makes sense to keep it is smaller than the green. So it makes sense to keep the green where it is and try for the red to have a bigger height.
Oh,
So it
okay, I
moves
see.
for a chance of a bigger height. It comes here again, it is still smaller, still smaller, still smaller. It stops here, but still, it has tried all the combination with the highest height, with the biggest height. If, for example, this one was here and this one was here, or let's put it first. Let's put it here. For example, and we start from here. In this case, this one is higher. Green is higher than red, right? So red moves forward. Now it has found the highest integer. Now it's green's time to move. And obviously we keep track of each volume that we go through. So each time you change a pointer, you calculate the volume, you compare it with the max, and then you move on. So in this case, this green is smaller than the red, so it moves and then it moves until it can't move no more, and then you have the maximum. Does it make sense?
It does. But
Okay.
it's still tricky. For example, okay, put for example the green on the initial. Now, if now is red gonna keep moving until it gets close to the green, then it starts?
It keeps moving as long as it is smaller than green.
So like this is like a loop. It move, then it calculates again. It move, it calculates again. Is that?
Whatever height is smaller, whatever pointer points to the smallest height, it has to change.
Okay.
If red is smaller than green, then it has to move. If green is smaller than red, then it has to move.
And each move we calculate the current and the max.
Yes.
Okay. Okay.
In this case, you focus more on the biggest heights, ignoring the smaller ones.
Okay. Makes
All
sense.
right, we got it.
Yes.
So again, we have a max. And then now we have two pointers. We have our red that starts at 0, and then we have our green that starts at the end of the array, which is the length of height. +1. -1? -1. So the latest index. Okay? And then we have a while loop. This while loop is gonna keep running as long as these two don't intersect. Right? We don't care if they're in the same index. We don't want them to be. So this, as long as the green one is on the right and the red one is on the left. We can call them left and right for simplicity. Oh, good. Right. So the green one is on the right, is on the end of the array. The left one is at the beginning of the array. It keeps looping until the left one is basically, it keeps looping as long as the left one is smaller than the right one. Because if they intersect, then we don't need that anymore. This is not a container, this is just a line. Okay? So while L is smaller than R, while the left is smaller than the right, then we do this. We calculate the current. It's the same thing as we did before. We calculate the current between the two distances. In this case, it is very obvious. It is left minus right because these are indexes, and right minus left. These are indexes, so it's easy to calculate. And then again, you calculate the max between the two, between the current and the overall max. And now it is the part where you check whether L is smaller or bigger than R. So in the case where if L is smaller than R, which means L needs to move, the left one needs to move forward, right? So L is gonna be L +1. Else, we move the right. So either if they are the same or right is bigger than left, then we put the right one backwards. Right equals right -1. And then it loops again, it checks, it calculates, and at the end of the while loop, you return H2O. Does this make sense?
Yeah. Do you have any question? Do not be shy. Can write in the chat or like open mic and talk.
Let's rename what?
Shadow wanna rename the L height.
Also, what big common number are you talking about? Awesome. If L and R are indexes, yes, then you either increment or decrement them. You modify the pointers themselves.
Yeah, but like, sorry, can you hear me?
Yes,
Yeah.
I can.
Okay, cool. So we're checking for the condition. We're checking for the height, right? To know which one is lower or which one is higher, right? To know if you are moving the pointer. So I'm saying we could change the condition. Yeah.
I understand. Yeah, we don't compare the indexes themselves. We compare the
value,
actual
yes.
height. Yeah. So it's
I did not
height
catch that.
of height L and then height R. Okay, that's good. Yeah, this makes sense. All right, is it clear?
Yeah.
Okay, then we can code it. All right, we start with a max of 0, with an L of 0, with an R of length of height -1, and while the left is smaller than the right, now the current is going to be the minimum between the two heights. So minimum between height L and height R times the distance. Since L and R are indexes, it is so very easy to do. L minus, or R minus, since R is bigger. R minus L. The max is going to be the maximum between the current and the max. So it's going to be max O and our current. And if the height of L is smaller than the height of R, then we increment L. If R or if it is equal or the height of R is smaller than the height of L, then we decrement L and we return our H2O. Let's see if this works. Oh,
I think one parenthesis.
Yeah. Oh. Okay. Yes.
Ooh, submit.
And it does.
Nice.
Because this is much faster than the previous console.
That's interesting, really. I need to work this one alone and see if I can like practice it. That's really interesting. Thank you.
Okay. I hope it was clear. I hope everything was well.
Yeah. It was perfect. Like also to see that the way we did it in the beginning, it worked, but it wasn't working efficiently. Like we were losing time calculating something that we already know that It's not gonna be bigger.
Exactly. Yeah.
Nice. Thank you. Thank you.
Of course, anytime.
Okay, we're gonna end here, guys. Thank you for joining. See you next week, Sunday, with another LeetCode. If you guys wanna host some LeetCode or something, reach out to me. That's it. Have a good night. Good night. Good night.